manufacturer, electrical cable manufacturers are there who is manufacturing the cable. Okay. For the LV 1.1 kV, this is the voltage grade of the LV cable. Okay, low voltage cable. For the ST, voltage grade will the voltage grade B is the insulation for this cable is designed for this voltage. When I'm telling PVC cable, the meaning of this is insulation is PVC. When I'm telling XLP cable means insulation is XLP. XLP stands for cross-linked polyethylene. PVC stand for polyvinyl chloride. Okay. So now,
No.
hello. If anyone wants to ask, he can, he or she can unmute and then ask. Otherwise, try to be mute. Try to be on mute only.
Continue.
Okay, so this is the cable cross section. So I will start from the inner part. Inner part is basically the conductor. That inner part can be aluminum and it can be copper. In India, what we are doing for the lower cross section, like 10 or 16 square mm, we are going for the copper, and more than this, we are going for the aluminum because of the cheap, because aluminum is cheaper and its weight is also lesser. So it is easy to install. But there is no such rule which will compel us to use the copper cable or the aluminum cable. Okay, we can use any cable. Everything depends on the our budget. Okay, and how we can handle it. Okay, so there is no rule for that. You can see here that the conductor is made from small wires, right? Means suppose I am talking about the one phase. This is the B phase. So this is made for small wires. So this question is for the new people. So are you familiar? What is that called? This conductor, one phase is divided into small wires. What is it called?
Friends.
Yeah, strands. So basically, what is the purpose of the strands?
Current carrying.
Current carrying, every conductor will carry the current. What will happen if I am making it in strands?
Flexibility.
Okay. Flexibility is the mechanical advantage. What is electrical advantage?
Distribution of current.
Eddy current.
Distribution of current.
Minimizing eddy current.
Eddy current. Okay, eddy current.
Minimizing.
See, the right answer is the skin effect.
Okay.
Skin effect is whenever we are passing the AC current from the conductor, most part of the current flows from the surface, means the inner part will remain vacant. So what the vendor is doing, he is basically dividing the higher cross section into small wires so that they can proper utilize the entire conductor. Okay, so this is called the strands, and these are used for reducing the skin effect. So this is conductor, and above this it's a insulation. This insulation can be XLP or this can be PVC. Okay, PVC cable means insulation is PVC, XLP cable means insulation is XLP. XLP insulation is having better properties as compared to the PVC. But if we talk about the flexibility, PVC is much more flexible as compared to XLP. XLP is the cross-linked polyethylene. Basically, say we are heating the vinyl chloride. Sorry, not the granules are there, which we are doing the cross-linking at a high temperature and the pressure, and due to this, the cross-linking of the polymers occurs. So this insulation is manufactured this way. So this is insulation, and it's a color code for India, RYBN. Okay, conductor insulation, then it's a inner sheath. Any idea what is the purpose of the inner sheath? Hello. Okay, above the inner sheath, you can see that it's a armoring. So armoring is a metallic part which can damage the insulation. So just to protect the armor, this insulation, this extra layer is added, which is called the inner sheath. And it is only used whenever there is a armoring. So to protect the material, to protect the armoring from the to protect the insulation from the armoring, this inner sheath is added. This is once again the PVC. Okay, and out of this inner sheath, it's a armoring. So this armoring can be GI or it can be aluminum. For the single core cable, the armoring is aluminum, and for the multi-core cable, the armoring is GI. This armoring is basically used for providing the earthing continuity, as well as it provides the mechanical strength to the cable. Okay, for the lower cross section, this armoring is generally wire armored, and for the higher cross section, it is strip armored. It is general use, not a rule. Okay. Above this, it's a outer sheath. Outer sheath basically protects the cable from the mechanical damage. Okay. Any question on this? The construction, conductor, insulation, inner sheath, armoring, and outer sheath. Okay. Any question on this?
No.
Yes.
So nowadays you might have seen that we are procuring the FRLS cable. FRLS is the fire retardant low smoke. So whenever there is a fire, the smoke generation will be lesser in case of FRLS. Okay.
So, means however, CVRP will be the same, no? Whether it is FR or not, non-FR.
Sorry.
No, CVRP will be the same. If any fault,
CBRP.
no, if CVRP will be the same if any fault occurs for FR or non-FR.
No, FR is the fire retardant property. It is not related to the fault.
No, I'm not
Okay.
talking about fault. No, it's only means fault is okay, right, yeah. Fault is sustainable.
Fault is basically
Okay.
this conductor is designed based on the fault. Okay.
Only for the smoke purpose we are using fire retardant.
Yeah, fire retardant low smoke. So whenever there is a fire, smoke generation is high in case of normal PVC cable. Okay. In fire retardant, we are adding some fire retardant granules, and because of that, fire retardant properties arises, which is like oxygen index, temperature index, or acid gas generation, and the smoke density. So these are properties which are basically added, and because of that, the cable says fire retardant.
I have a question. This fire retardant cable, does it has any additional property of extending the fire, surviving the fire for long hours, something like that?
Yeah, that is called the fire resistant cable. This is fire retardant low smoke. It basically it is provided on the insulation. So if you are using a fire resistance cable, so for that we are adding one mica layer over the conductor. So that is used for the fire resistance cable. That is different cable. A FRLS cable does not have that property.
Okay,
It's
so this is
basically
like a normal,
see this.
same like normal, only the smoke control will be there, that's what, right?
Yeah, it's a small controller. Suppose you want to have it the more working properties of the cable in case of fire, then we have to go for the fire resistance cable. Okay, so in that what we are doing, we are adding the mica coating. Mica layer is added over the conductor. Because of that, basically the cable can basically cable can be used for the longer duration. Okay, that is different cable.
Okay.
Okay. Now it's a color code for the India, RYBN. Like this, every country is having different code, so this is used. This is once again the okay. So this is that cable. Now whenever we look at the cable, there are some codes are defined on the cable outer sheath. Basically, with the help of that, we can identify the type of the cable. See what is the cable construction of the cable, and that is basically provided on the outer sheet. This is called the cable numbering. So code letter says copper is having no code. Aluminum, the code letter is A. This is used all over world. PVC insulation is Y. Round wire armor W. Strip armored F. And PVC outer sheet is Y. So basically, with the help of these code letter, we can identify the type of the cable. Okay, suppose I'm telling 444 square mm. Okay. 444 square mm means the 4 square mm is the cross section of the conductor, single conductor, not the entire cable. So 4 square mm means every conductor is having the 4 square mm cross section, and the A by W by A is aluminum conductor, Y stand for PVC insulation. For the PVC insulation, the code letter is Y. If it is XLP, then code letter is 2X. W is the wire type armoring and Y is PVC outer sheath. Okay. Okay, so any new person can just explain this cable 3.5 for 50 square mm. Anyone wants to explain 3.5 for what is this half for?
Neutral.
Half core is the neutral.
Okay, so neutral
That is
is
the
half.
3 is the phase cable. That is the half is the neutral cable.
Okay, the 50 square mm is the phase conductor and neutral is just half, so that is 25 square mm. Right? Rest is
Yes,
the
yes.
cable code letters. So A means aluminum, Y stands for PVC insulation, F stands for armoring, and Y stands for PVC outer sheet. Okay, so simple cable. If it is
F means
XLP, F stands for armoring, strip armored.
strip arm. Okay.
Okay. So this is defined here. Okay, so with this we can identify any cable. Whenever we are procuring the cable, see, I request everyone to mute yourself if they are not asking any question, so that other will not get disturbed. Okay. Otherwise, I have to mute. Okay. Whenever we are procuring the cable, so we are getting some mechanical as well as electrical properties from the vendor. Means what is the current rating, what is the cable resistance, cable reactance. So this property we will get. Okay. So
Yeah.
yes, you can ask. Yes.
Yeah, I have a doubt. Yeah, you are telling PV insulation as well as PVC outer sheath.
Hmm.
Yeah.
Yes.
So in the DC cables, we'll be using only the PVC insulation. If it is a 4 square mm cable or whatever it may be, small square mm cables. Yeah.
See, this
Only
cable
PVC.
can see DC. You are asking about a DC, right?
Yeah, DC
DC
cable.
cable,
Yeah,
right?
DC.
DC cable means only two phases will be there. Okay,
Hmm.
R, Y. Rest thing can remain same. There is no change in the cable.
Okay. So in
Okay.
AC, we'll be giving two types of insulation, whether it is cross-linked PVC or PVC or XLP PVC. As we are
See,
using
when
two
I
types.
am telling XLP cable means insulation is only XLP. Rest everything will be PVC. Mean the
Okay.
sheath will be PVC only. Insulation is
Okay.
only XLP.
Okay.
XLP means insulation is XLP, rest the sheath will be inner and outer will be PVC.
Okay. Okay. What is the material of this inner sheath? Is it only is it
PVC, rubber, PVC, polyvinyl chloride.
Yeah. Okay. There will be only the thickness difference between outer as well as the inner.
Yeah,
That's it. Okay.
see, this is defined in the cable data sheet.
Okay.
Okay, so not too much difference, but yeah, difference is there. Yeah, that the vendor can. It's not a big thing.
Okay.
Okay, so vendor will define the electrical and mechanical parameter. Mechanical parameters mean the resistance and reactance. Sorry, mechanical parameters. What is the cable dia? What is the tensile strength of the cable like that? Electrical means AC resistant, DC resistant. What is the current rating? Current rating in ground, duct, and in air. In air means whenever I am laying my cable in the overhead, so this is the current rating. Whenever I am laying my cable inside pipe, so it is called duct formation. When I am laying in the direct in ground, so it is called the buried. It is direct in ground. So vendor will define the current rating. Okay, so this cross section is available from 4 to 1000 square mm. So this is the vendor data sheet. So 4 square mm to 1000 square mm. So this is for the single core cable. Okay, so any question on this? Okay, so this is the cross section. This is thickness.
I
It's a
have a
R1.
question.
Hmm.
Do you have a calculation for that? How do we calculate this?
What?
Current calculation on this?
Current calculation, why do you want to calculate the current? The vendor will directly see, we will do the cable sizing, but this is the size, this is the current which the cable can carry. Based on this, we will size our cable size based on the requirement. See, the vendor is telling my 4 square mm cable can carry 27 ampere, but we will basically verify based on our loading. So that calculation we will discuss based on the loading. It is the data which the vendor provided that their cable can carry how much current. Okay, see,
Building cables.
we will
Do-
do the sizing of the cable based on the load, but we should also know how much current that vendor can, how much current the vendor cable can carry. We should also know this, right? So that is this parameter, this value.
No, the main point why I asked is, suppose here the length of cable laid is not calculated for the current. Suppose if it is 10 meter, the current what we have given is okay. If it is for 200 meters, 300 meters, then the current will vary, right? Because
So
of the
why?
voltage
No,
drop.
no, no, no. Only the voltage drop will change.
Correct.
Current will not change. Okay. Current
Yeah,
will
voltage drop
change.
will vary, correct.
See, voltage that we will calculate. It will be the part of the cable sizing based on the load. Just after this introduction, I will move toward the sizing. So just
Okay,
give me
okay,
some
go
time.
ahead.
This is the input data which we're getting from the vendor.
Okay, okay, go ahead.
This current is the standard current ratings or any
It's
if
a manufacturer standard.
manufacturer only manufacturer standard. Different
Yes.
manufacturers having different standards are there.
Not too much different, almost same. See, if it is 32 ampere, maybe 33 or 31 like that only. Only see almost same. Otherwise, no one will procure their cable, right? Why will you procure their cable if the current rating is less? But
Okay.
everyone has to sell their cable. So like this, data is given by the vendor for the single core. In single core, this is the unarmored, so this is the current data. So we will use this data in the sizing calculation. This is for the copper conductor. This is for the twin core means 2 core. Okay. Here the resistance. Whenever I am passing the AC current from the cable, I will use the AC resistance. Whenever I am passing the DC current, so I will use the DC resistance. Okay. So this will be used in the sizing calculation. AC current is always higher because of the skin and proximity effect. AC resistance is always higher, sorry. Okay, twin core copper. It's a 3 core aluminum. Any doubt in any parameter, any technical parameter? Otherwise, I will move to this derating part. Any question on the any parameter? Like what is this weight is mechanical thing, not this is the DC resistance. This is the current rating whenever I am laying cable underground. This is in duct and it's in the air. Okay. Shall I move now?
Yeah.
like this, every vendor, Polycab, KEI, KEC, COTS, Draka, Nexus, many reputed vendors are there. So those cable can be used. Here it was the DC resistance. So now here it is the AC resistance. So it's here resistance, reactance, capacitance. So this will be used in the sizing calculation. Voltage drop is also there. Now see, vendor here is the vendor here is telling that his 2-core copper can carry 2-core copper 400 square ohm can carry 530 ampere in the air. It doesn't mean that it will carry 530 ampere in all the condition. There is some certain condition it defined for the cable. Okay, so this is called a derating. Means if you are operating your cable under any different condition, the current derating will occur. Okay, so that is called the derating. Are you familiar about this? That every electrical equipment is having the derating because of temperature, altitude, like that. Everyone is familiar, apart from the old student. New student, are you familiar that every electrical equipment is having derating? I mean, it is a simple thing, no? Everyone is having the limitation. If you are operating any equipment under any different conditions, suppose you just
But
take example of the VFD. Suppose if you are not operating the VFD in the AC room, if you are operating it in outside, so definitely something will happen, right? Means the VFD current rating will reduce because of the temperature, right? So like this, it is happening with each and every electrical equipment. For that condition, I will explain now. You are familiar with this?
yeah. Can you please also explain that how altitude affects the derating factors?
See, okay. See,
Yeah,
okay.
indirectly.
Just assume you are going on the mountain. So we all know that oxygen level will go down, right? And we are having the, not we, everyone is having some breathing issue. Some people are having the high and some people are having the low, right? This will happen. Means what is happening at the mountain, oxygen molecules are basically spread because it's above from the ground. So क्या होता है, जो molecules होते हैं, oxygen molecules that are spread. So we require more oxygen, right? So ऐसे same will happen for the electrical motor for the equipment. So we require more air to cool down. So because of that, the derating will occur. It may is it understood now what
Yeah,
I'm
yeah,
trying
yeah.
to tell?
Yeah, got it, yeah.
Because of the spread,
Drop.
molecules will spread. So this is the case for each and every electrical equipment. Generally, equipments are designed for 1000 MSL. Okay. If the altitude is more, then definitely the rating will happen, and the manufacturer will tell how much we need to derate. Okay.
Okay.
So as I told earlier that the next thing is, whenever we are doing the sizing calculation, remember to use the correct catalog. Means this is the cable catalog which is for the IS standard. So we cannot use this catalog for sizing the cable in the UK because the conditions are different and the temperature is different. So in that, we need to use the IEC or the BS. So this thing needs to be understood. So whenever we are downloading any catalog, always look at the catalog. What is the standard it is following? So this is IS. So it is only for India, not for outside. For outside, we used to use the IEC or local standard, correct? Or which the country is following. Okay, so first thing is the ambient air. As I told earlier that vendor is telling that my cable can carry 100 ampere. it doesn't mean that that can carry 100 ampere in all the conditions. That is some certain condition on which that is applicable. So that is called the ambient air temperature derating. Here you can see at 40 centigrade, the factor is 1. When the temperature increases or decreasing, there is the derating factor is there. So suppose your ambient temperature is 80 and vendor is telling that my cable can carry 100 ampere. So if you are operating your cable at 50 degrees centigrade, you need to multiply 100 by 0.8, means your cable will carry only 80 ampere. Correct? Got this? So
Yeah.
this is called the ambient. So this data is basically required whenever we are sizing the cable. Okay. So first is called the rating factor, which is the atmospheric condition. Second is the ground temperature. Ground temperature is applicable in case of buried cable. So which is 10 degree lesser. So it is 40 degrees centigrade and it 30 degrees centigrade. So cables are designed on 30 degrees centigrade ground temperature. Next is the cable in duct. So whenever we are laying the cable in the duct, this will be applicable. Okay. Next is the depth of laying. In India, cables are designed for 750 mm depth of laying. If the depth is more, you can see the derating factor is there. So that needs to be used whenever we are sizing the cable. Last factor is the thermal resistivity. Every soil is having different properties, and because of that, heat dissipation will be different in the soil. So this is that factor which will take care of that part. Okay. So this data is basically required from the client. They will basically do the soil survey, and based on that, the inspector will measure this thermal resistivity value of the soil, and that is used in the sizing calculation. So in
What is-
India, yes,
Yeah. What is the standard considered by the cable manufacturer? Whatever it may be, the make.
150 degrees centigrade, centimeter per watt.
Okay, 150 degrees centigrade. Okay.
Yeah,
Plus
this
or
is
minus
for
of
the
that,
India. This is for the India.
okay. Further derating factors we should calculate.
No.
As
Why
per
you
the
are, see, your client will give you 200 or 250. It is directly mentioned, na? You need to multiply by 0.91.
okay. No, directly measurements at what temperature he is confirming that value.
See, the client will provide you this value now. What is the thermal resistivity of their plant, of the plant soil?
Okay.
So this value we will get from the client. We are not calculating. We are only taking the input from the client. What is the thermal resistivity of their plant soil? So this for that they will appoint an inspector, which will measure this value, and accordingly we will get this input.
Not regarding this table, actually in the cable datasheet, the current carrying capacity you were telling us that at what temperature they have considered and given the data sheet.
That is what I'm telling. If you are using the IS standard, if the vendor is telling that my cable is as per IS, so it is on 40 degrees centigrade. So this we need to see what standard vendor is following. If it is IEC, let me open IEC. So we need to get it from the vendor only. They will write this. That it is on 40 degrees centigrade. If it is IEC, IEC is telling on 30 degrees centigrade.
Okay, that will be our cost. Yeah.
Yes. This condition they will define. And condition is coming from the standards.
Okay.
There is some noises coming from your side. You can come to some different place. This is the IEC. So in this, it is defined on the 30 degrees centigrade. If the temperature is different, accordingly it will change. So we should first download the correct catalog and follow the correct standard for sizing the cable. Okay.
It's not my.
Is this applicable for non-armor cable also?
See, it is for the conductor. Forget armored. It is not related to the armoring. It is for the conductor current. Okay.
No, no, these are temperature values, sir.
Temperature is not related to the armored or unarmored. That's what I'm telling. It is the cable current which is related to the cable conductor.
Only conductor.
Rest is the protection. The armoring, non-armoring, that is the protection only. We are tying the cable, means we are designing the cable cross-section, means the conductor cross-section based on that.
Okay, okay.
So if we do this properly, means we are following the correct standard. Okay. So this point is clear. Rating factor is clear.
Yeah.
Yeah, there is some noise is coming. Who is that? Yeah, Mohammed Faisal.
Yeah, it's unable to mute here. That is the problem. I'm trying to mute.
Okay, I mute you. You can unmute yourself whenever you are asking any question. Okay. So it's a rating factor which we have discussed. Now, second is the group rating. See, in the plant, we are not using a single cable. There are multiples of cables, and because of spacing, number of tires, the group rating arises. And this is this depends on the single core and the three-core cable. So everyone understood the trefoil formation? Question is for the new people only. Trefoil, you understand? Whenever we are laying the single core cable, we should make a trefoil. So trefoil is like this. So it's a trefoil formation which you can see right now. Okay, so the cables are basically laid in a triangular formation. This is called a trefoil. Okay, clear? It's for the new students only, because all people are new. Okay.
What is the specific purpose of this?
This is used. See what we single core cable means we are using the one core for one phase, right? Then what is basically happening if we are using it like this, the flux cancellation happens. See, RYB is the phase which is carrying the current in the 1 to 20 degree phase difference. So if we are making like this, the flux cancellation occurs in the outer part. So the heating will be lesser. Okay, because of this formation. So that's why this is used, this trefoil formation.
You mean to say this will be followed by all the manufacturers you are telling?
This will be?
Followed by all the manufacturers for the cable.
See, no. This is not the manufacturer.
Okay.
We have to lay the manufacturer cable like this. If we are laying the single core cable, we should prefer this configuration.
Okay. In trenches.
Manufacturer will.
If we keep this cable in flat condition, will there be any issues, or you have to maintain any specific rule? For example, I cannot keep some places. I cannot keep the trefoil. Some site condition. I have some site area. I cannot keep. I cannot maintain.
That is the good question. Okay, let me explain you. See, this method is basically recommended when you are using the cable for the transformer outgoing. See, if you are using it for the motor is a balance load. Okay, means all the phase will carry 120 degrees centi. This phase difference will be there, and your motor will rotate. So this is not compulsory for the motor, but it is compulsory for the transformer, because transformer outgoing is the unbalanced load. So we should use this in that fashion. Suppose if you are not able to use it, then IEC has also defined the derating in that condition. Flat conditions also. So this derating will be used in that case. So it is for the multi-core and it is for the single core. So if it is a like this flat condition, then this derating will be used. Mean derating will change in that case if you are not following that criteria.
Okay.
But technically, it should be used, preferably should be used for the transformer outgoing, but not compulsory for the motor. But at a rough practice, we are using like this.
Okay, sir.
You are in which company right now?
Me?
Yes, you asked this question.
Atkins, sir.
Atkins Global.
Yeah, Atkins, yeah.
Okay.
So always, we are facing this problem, this fight, between the contractors and so
Yes,
this fight will be there.
See, not compulsory for the motor. Okay, because motor is a balance.
Then our case is always transformer. Our case is always transformer only.
And
So
it says see, if you are not able to use it, just get the proper derating factor from the vendor that you are using in the you are not able to do it in the trefoil formation. Get the perfect derating factor from the vendor. Then only lay this cable. Okay. Because the heating is more.
Okay.
And current derating will occurs more in that case.
Okay.
Client vendor.
I have to know this.
Yes.
If the transformer is of heavy load or something is remotely connected, then you will have multi runs of cables. For example, R phase itself, you will have 3 run, 4 run. Same like that, R phase, Y phase, U phase. So how will you apply this?
Why will you not apply this? See, okay, let me tell you once again what we are doing in this case. This is R, this is Y, this is B. This is one set. Like this, second set will be used. R by B, then again R by B, then again R by B. Okay, let me tell you once again. Suppose you are having 4 runs in each phase.
Right.
Okay, trefoil will be made, but it will be like this. Let me come to the picture. This is RYB. This is RYB. This is the first run. This is second run. Third run. This is fourth run. And this spacing is 2D. Okay. So basically, we are distributing the phases. So one set will be made like this. See, okay, let me come to the multi-core cable. In multi-core cable, we are already making this it like this. Cables are in rectangular. So it is already in this that shape. For the single core cable, we are making this shape by laying the cable in this condition. Okay. So it will be like this. This is R by B. Then again second run R by B. Then again it is like this.
I agree with your comment, but I have seen multiple places they have taken it as a straight in the horizontal zone. So multiple strands, multiple runs will go there, but I didn't see any such type of trifoil there in multiple places.
Okay, see, that is what I'm telling. If you are not able to lay your cable, technically you should use the proper derating. See, in case of single core cable, if you are not able to make it trefoil, if you are laying like this, then correct derating factor should be used. In the derating factor will change because the heating will more in that case. So as per the condition, we should use the correct derating factor. See, it's a trefoil formation. This is the factor. In case of flat formation, this is the derating factor. So this data should be correct in that case.
I have one question here.
Boliye.
Trefoil formation is installation method is it is only on the above ground or below the ground we can make the trefoil formation, because there they mentioned the trace.
It is not related to the ground or that underground and overground. Okay.
Okay.
It doesn't mean that you should get this data from the vendor. Okay. They will provide you.
Okay.
In the duct also, they will provide you. Every data they will provide. Okay. You should guess this data from the vendor. Here it is mentioned, this is for the air, it is mentioned. But for the duct also, the vendor will provide. In the IC, it is there. This is for the 3-core cable.
I have
It
one
is for
more.
the single. It is for the single core cable. You like this?
Yeah, I have one more doubt on that. Sorry to ask multiple questions.
No problem. In any asking any questions.
See, basically in the transformers, there are two sections of transformers. One is on the input of the transformer, and the second section is either step down or step up of the transformer. That is going to the load. Okay.
Okay.
So this mainly affects on the input side or on the load side, where the focus needs to be.
It is only for the single core cable. If you are using the single core cable at the input side, you should use trefoil formation. If you are using at the output side, you should use trefoil. It is applicable only for the single core cable.
Either on both input or output.
Yes, either both or either at one side.
Okay,
it is for the cable cross section, cable core, whether that is single core or multi-core.
Okay, thank you.
Excuse me. Any standard distance is there for the distance between the clamp to clamp?
2D. It's a general derating which the vendor will give you. Twice the diameter. It's a typical use. Okay, typical standard practice, but it's not a standard. Let me show you. Suppose this is the cable. Vendor defined in the touching formation as well. They are defined in the 150 centimeter as well, 30 and 50. So if you are using in the 2D, then accordingly, as per the spacing, this will be changed. So generally it's a 2D, but not a standard. Twice the diameter. It's not a standard. So accordingly, this derating factor will change. So you should use the derating factor as per the installation condition in which you are laying your cable. So this will come from there.
Okay.
Like this. Twice the diameter. Okay. So this is for the cable laid in ground, single core cable. This is in the duct. This is in the trench with tray. And it's in the open air. Now it's a multi-core cable. Now, just is a question for the new one. There are two conditions defined by the vendor. One is A and one is C. So basically, just for the saving the cost means I want to save the material cost and the installation cost, which either A or either C. Which one I should use? Just read the A and C and tell which one will be applicable. Hello, can you hear me? Hello.
Yes, we can hear you.
Okay, please read sentence A and C. So which one you should use? A or C? Okay, let me explain now. In A, you can see cable spaced wire 1 cable OD. So if we are using this factor, we need to lay the cable wire providing 1D spacing between the two cable, right? Means the tray requirement will be high and we cannot, and we require the more supporting. more width in the tray, correct? But if I use the C factor, cable touching, then in that case, you can see we can basically save the material, save the installation cost. Okay, clear? Because it's in that touching formation, and we can lay more cable in one tray. So it will, because of this,
But sir,
we
sir, there is a derating factor is different, So
yeah,
it
it is
may
different. See, yeah, it can be. Yeah, see, it could be, but overall, I think this will provide you more saving in the material.
more savings. Okay.
Yeah, overall, it will be the more saving. Okay, so that was all about the basic part of the cable. Any question anyone wants to ask? Now I'm moving toward the sizing calculation. Any question anyone wants to ask? Hello. Where are you all? Means Cebu is there in this session?
Hello.
Yes, yes, I can hear you.
Yes, sir. We are here.
Okay, okay.
Okay.
Okay, so any question on the basic part of the cable? Now I'm moving towards the sizing calculation.
Yes, sir.
Okay. Let me explain something on the ST cable as well, so that things will not be skipped. So the first point is, whenever we are downloading any catalog, first look at the standard which the cable manufacturer is following. So this is based on the IEC. So always remember to track this. This we should understand. In the ST and LT, the difference is only the insulation. When the voltage increase, current decrease, but the thing is, insulation requirement over the conductor will increase. Means the insulation thickness will increase. In case of LB, if the current is increasing, just increase the cross section. But in case of ST, if the manufacturing designing any ST cable, he will use the more insulation thickness. Okay. So that is a change in the ST. So it's a conductor. Then you can see over the conductor, it's a black part. So it is the conductor screening. It's a insulation. Then another black part, which is called the insulation screening. It's a copper tape, which is used for the earthing. It's a rubber below, inner sheath, armoring, and outer sheath. Okay. So it is the change in the ST cable. The copper tape is generally used for the ST cable and also for the VFD cable. It will come by default for the ST cable. But we need to ask to the vendor to provide the copper screening in case of LT cable. Okay, it is generally used for the VFD based cable. Now, this is the voltage grade. One is the 19/33. 19 means it is the voltage grade between the phase to earth. Means phase is this and earth is spinning. So between this, the insulation is designed for 19 kV. And this is 33 means phase to phase. So insulation is designed for this voltage between phase to phase. Whenever it's a unearthed cable, phase to earth is 1/√3 of the phase. Whenever it's a unearthed cable, so insulation between the phase to earth is 1/√2 of the phase. Whenever it's a unearthed cable, then both will be same. 11/11, like this. Phase 2 what is equal to the phase 2 phase. Okay. Similarly, current rating is also given for the ST. So accordingly, we will use this. But always look at the condition. It is as per IEC, so the temperature is 30 degrees centigrade. So we should concentrate on these conditions as well. For sizing proper cable. Okay. Any question on the ST cable?
Sir, is there any
Can-
regulation?
Is there any?
Is there any regulation or requirement to follow both phase to earth and phase to phase has to same need to maintain the same value, or we can have different values?
Same value means same value for what?
Phase to earth and phase to phase, because phase to earth and phase to phase both are accidents, you know. So we need to maintain same value or
Oh, I think I am need to explain once again. This is the phase to earth voltage.
okay.
In the insulation for this phase 2 will be designed or okay, let me explain in another way. Phase to earth means whenever I am grounding my system, transformer neutral is grounded, so that system is called the phase to earth. Because what will happen? Suppose the earth fault occurs, current will flow to the ground and return through this neutral. So you are getting some path. In that case, insulation of phase to earth can be 1/√3 of the phase. But if we are using the phase 2, suppose if it's an unearthed cable or unearthed system, means I am not grounding my system or grounding my system through the NGR. This is not grounded. So in that case, the insulation requirement will be high because phase to earth voltage will increase in case of earth fault. So accordingly, as per the system earthing, this requirement will change.
Okay.
Now, I'm coming to the sizing part. Sizing.
Excuse me, sir.
Okay.
Is there any semiconductor is there in HT cable? Semiconductor layer. The
Yeah,
ore of the
this, yes.
why
See,
it is required?
let me come to that point. See, over the conductor, you can see it's a black part, right? It is called the
Yes.
screening. So this is conductor screening and this is insulation screening. What is the semiconductor? Is just like an insulator, not imperfect insulator, but insulator. So it is confining the electrical field within the conductor only. That's why this vendor is adding this another layer. So that this electrical field will be confined within this conductor only. So this screening will come by default in case of ST. Because the voltage is high, it can puncture this single insulation can puncture. So that's why these two layers are added.
This black part is the semiconductor, na?
Yes, this is semiconducting compound. Okay, this one, semiconducting layer.
What is the specific purpose of that?
What
would be the specific purpose of that semiconducting? Already we have the insulation here, right?
See,
The
this
white part is
insulation, see,
there.
for in case of high voltage, this single insulation cannot confining the electrical field within the conductor. It may puncture. That's why another layer is added. This is one layer, this is second layer. So that this high, in case of high voltage also, this insulation will not get punctured. Because a single insulation cannot protect it in case of high voltage. So that's why another layer vendor is adding. Okay. So that's why it is like this. He can increase the this insulation thickness, but at the same time, the cable dia will increase. So he is adding the semi-conducting compound, two compound to keep the field within the conductor only, so that insulation will not get puncture. Okay.
Okay. It is required to
Yes,
connect.
it's compulsory.
No, that is the another question. It is required to connect with earthing on both side of the cable.
In case of single core cable, we need to connect only at one end. In case of multi-core cable, we need to connect at both ends. This screening.
Oh, okay. Only single core cable is
Because in case of single core cable, if you are grounding at both the ends, then it's a closed path will be created. Then that will once again reduce the current carrying capacity of the cable. So that is not recommended. We are grounding at one end only. Okay.
okay.
This is applicable for single core and multi also.
Sorry, so
If,
single core.
if a single core cable has been earthed at both the ends, that
Yeah,
I'm not talking on the screening.
That case, yeah, in
I'm
that
talking on
case,
the armor. Armor is being earthed at both ends. Will it have a circulating current?
yes, why not? Closed part will be created, and that will further derate the current rating of the cable. So that is not recommended. Armoring, either you can earth armoring or either you can use screening. You should use something, no? Generally, we are using the screening in case of ST, because for on armoring, we cannot depend because it will corrode after some time. So we are depending on the screening only.
Okay, actually, I asked it very specifically why, because I have seen on the EHE cables, especially on 600 square mm cables, where I could see that earthing has been done on both ends, or because it runs for kilometers, 2-3 kilometers. So we could see that it is earthed at both ends. Is
I
it
don't think
correct?
so. I don't think so. One minute. Just 1 minute. See, there will be some okay. In case of EHP cable, they are using these methods also, both the ends as well as single end also. But for the high voltage cable, very high voltage, okay, both methods can be used, single end as well as for the both ends.
Okay.
This can be used, but you should remember this screening should be pointed one end and then it is grounded. In case of single point, this SVL will be added. Yeah, you can use. Both methods can be used.
Is there any specific limitation or anything there that over particular distance it can be done, or
Yes. This is defined there.
because we have seen within a short distance, less than 1 kilometer or
Yes,
something.
yeah.
Yeah,
In
I
case
could
of
see
that
yeah.
this is in case of that smaller length is there, then they are basically telling this thing. In this method, When the see the length is lesser, they are basically telling for the single point bonding. If the length is more, then people are going for the multi-point bonding. The screening will be grounded both ends. As per the length also is changing.
Okay. Okay, thank you.
Okay. Now sizing part. Sizing we all know in the electrical, it is depending on the load, right? So if the load is higher, definitely our equipment size will change. Same will happen for the cable as well. Cable sizing basically depends on three criteria. One is rated current, second one is fault level, third one is the voltage drop. Okay. Rated current means as per the load current, we will size the cable. See, suppose our load current requirement is 100 ampere. So we will select the cable which can carry that ampere after providing the derating. Okay. If second is the fault level. Suppose the fault occurs in your system, your cable should be capable of taking that fault level. Mean cable should not burn in that case, fault case. Mean the cross section should be designed based on that. Third one is the voltage drop. Voltage drop means every cable is having certain length. Because of that, the voltage drop will be different. Okay. So this is the third factor. In case of LV cable, we will use only the rated current and the voltage drop. In case of ST, we will use only rated current and the fault level. I will tell you a reason later why we are not using third one. So it's a universal method which is used everywhere. Rated current, fault level, and the voltage. Okay. Now I'm taking the example. Both you are having the 50 kilowatt motor and the voltage 415. So current is √3 VI cos phi. We can easily find out. Okay. Is there anyone who is GAT in this batch? Means only 1 or 2 years experience. Hello? Okay, no one is speaking. Okay, so
No, no.
81. Okay, so 81.8 amperes current is the load current requirement. So your motor wants this current. Anyhow, the cables will provide this current, right? So your first step is rated current, means our cable should be able to provide this current. But what is happening? Suppose you are laying your cable in overhead condition. In the overhead condition, the derating will occur, which is called the overground derating, which is the ambient. First factor is the rating factor, which is the ambient air temperature. This will not only this factor will be applicable in case of overhead cable, ambient air temperature. Rest is for the underground, right? So suppose your atmospheric temperature is 50 degrees centigrade, which is the ambient temperature. The factor is 0.8, right? So I will write the 0.8 here. Second is the group rating. So right now we are not having any details. So we have assumed one condition that suppose we are having the this C condition I am taking as a rough right now because no data is there. What is that? Suppose I am using 3 cables entire and each tray is having 9 number of cables. So this portion I am taking 3 cable and 9 number of cables. So 0.68. So overall will be the multiplied of the both the factors. 0.54. So suppose you are selecting the cable which can carry 100 ampere, but after this derating, that cable will carry only 100 into 0.54 means 54 amperes. So that cable will be not sufficient for this current. Okay, so what we will do, we will divide this derating with this. Okay. So I'm dividing 81.8 divided by 0.54, which is 151. Okay. So I will select the cable which can carry 151 ampere. So I will once again go to the catalog. I am assuming that I am selecting the copper cable. So 3-core copper. Yeah, 3-core copper armored. Our requirement is 151. So it will come here, 165. So in air, 165. The cross section is 70 square mm, right? So means as per the first condition, I can take 3-core 70 square mm copper cable. Clear? First step is clear. What I'm doing here. This is the first step. All the steps should be verified. Otherwise, our cable sizing is not correct. Second condition is the voltage drop. As I told that every cable is having some certain length. So because of that, voltage drop happens. All your load should be capable of taking the, see, suppose you are running the motor. So minimum voltage should be available at the motor. Otherwise, motor will not run, right? So that voltage drop should be within the limited condition. Suppose it's a transformer and it's a motor. The general practice is 5% should be available. 5% drop is allowed up to the motor in the running condition and 15% in the starting. Okay. The general condition. So suppose this is my transformer, then this is the panel and this is motor. So from transformer to the panel, it is the 5%. Suppose if you are using one panel here and you are allowing 1% here, means from panel to the motor only 4% is available. Overall, it's a 5%. Suppose you are taking one here, then you can take panel to motor only 5%. Accordingly, you are suppose you are taking 2% here, then it will be 3% from panel to motor. So accordingly, it will be changed. Okay. So it's a overall from the source to the load. This voltage should be available. Okay. Clear?
Sorry, I missed it. Can you please repeat that alone?
Okay. This is the minimum voltage should be available in the motor terminal. So this, it is the minimum from source to the load. This voltage should be available. Suppose in between transformer and the motor, there is one more ST panel is there or the LV panel is there. So from transformer to the panel, one cable will go, and from panel to the motor, another cable will go. So there are two cables. So this cable will be sized on different voltage drop, and this will be on the different voltage drop. Suppose you are taking transformer to the panel, 1% drop if you are allowing. So as the total drop is 5%, so from panel to the motor, it will be only 4%. So overall is 5%. Overall should be 5%. Mean up to the motor, limitation is 5% only.
Okay.
That is
Okay.
depends upon the depends upon the distance or any other factor. That panel to motor and motor to transform. Panel to transform.
Sorry, which one? This percent.
Percentage.
Yes.
See, if you are allowing more voltage drop percent, for suppose the length is higher, then you should provide some more margin in the voltage drop, because lower, if you are not doing that, then cable cross section will be high. So what we are doing for the smaller length, we are going for the smaller voltage drop. For the high length, generally from panel to the motor, length is always high. So generally we are keeping it at the higher. Okay, we can do it 4 as well. This can be 4 and this can be 1. But cable size will be different. Means the cable runs will be higher in that case. And here it will be smaller. So that does not look good. It will be from the installation problem. So if the length is higher, keep more voltage drop margin. Okay, in case of me, that will be from panel to the motor. So it should be like this.
Okay.
But overall should be same.
Okay.
Now, voltage drop. Voltage drop is simple formula V equal to IR. If it is a AC, then IZ. Z is IR R cos phi plus X sin phi. If it is a three phase, then √3 IZ, correct? If it is a percentage voltage drop, divide √3 IZ divided by voltage. The same thing is done here. √3 I L is the length of the cable because R cos phi plus X sin phi divided by number of run into voltage into 1000. It's for the three phase. If your cable is single core, if your voltage is single phase, then it's a 2 into the √3. Okay, so it is like this. So it's a formula. Now, I is the rated current, L is the length. Length means from panel to the motor. This we can verify from the cable routing layout, 150 meter. AC, this R is the AC resistance. Whenever I am passing the AC current, always do the AC resistance. Whenever I pass the DC current, do the DC resistance. So this we can get from the vendor catalog. So this is also defined here. So my cable cross section was 70 square mm for the single core. And it's a multi-core or aluminum. Next page is copper. Armored. Aluminum. Aluminum. Copper conductor armored single core. Copper conductor multi-core. My cable cross section is 70 square, right? So this is the resistor and it's a reaction. So same value is used here. 3210.0.771. Number of runs is 1. See, number of runs means suppose your cable current requirement is 100 ampere and you are selecting the cable which can carry only 50 amperes. In that case, we will use 2 runs so that your current requirement will match. Suppose your current requirement is 1000 ampere and you are having the maximum cable which can provide only 800 ampere. In that case, we will go for 2 runs so that our cable current requirement will match. That is called number of runs. Then after putting everything in the formula, in the running condition, drop is coming. My limitation is 4%, so drop is coming 1.61. So starting current, so the running condition, it's okay. Then next is the starting current. Starting current means in this case, I will use the starting power factor for motor and starting current. In case of motor, generally, you can use this for the LB. You can go up to 8.4 times for LB and 6 times for the ST. Okay, this is the of the running current. So starting current, it's a LB motor. So starting current is 8.4 times of the running current. Starting power factor is generally 0.2. So this we can take. It is given in the manufacturer data sheet. So this we can get from there. Starting current and this. So cos phi and sin phi. Sin phi will be the 1 minus cos square theta. So this is put in the formula. In the starting condition, limit is 15%, and we are getting 6%. So,
Hi sir, one more thing. How we can get the starting current?
Starting current you can get from the vendor data sheet. But
It
as of
mentioned
now,
that
yeah, depend on the efficiency class of the motor. But as a
yeah,
general
it's
rule,
mentioned in the motor, right?
it's on the
It's mentioned on the motor data sheet.
yes motor data sheet only. But right now we are not having anything. So generally
Okay.
it is like this. It will not go beyond this 8.4 for LB, 1/6 time for the ST.
Mhm.
So we can use this. 7.22 is also there. Anyway, this we can use. So means in the running condition and voltage drop, my 3-core 70 current copper cable is okay. Any question on this sizing? We are sizing this LV cable based on the load. I hope this is
Yes, sir.
clear.
I have one.
Yes.
Yeah, I have a question.
Yes.
Regarding the voltage drop percentage, you are mentioned 1% plus 4%. Is this only for your assumptions, or is there any IC standard you are mentioned for 5% voltage drop?
It's not a. It's a recommendation from the motor manufacturer. This voltage should be available. Minimum voltage at the motor terminal.
Voltage drop they are recommended. It's like 4%. They are recommended.
Yes.
4%
No.
or 1%. Like
They are telling my motor should run continuously when the voltage variation is 5% drop is there. Maximum 5%.
okay.
So it's not a standard. It's a general practice.
Okay. So this is from the motor manufacturers only. They will provide us this data.
You should size this cable based on this only. But yes, motor manufacturer, this comes from the motor manufacturer only.
Okay. And also
It's
the value cost and also the value cost theta 0.85 where you can get this data.
It's the
Cost.
motor power factor, which you can get from the motor data sheet.
Okay, thanks.
Can you
Sir,
repeat
this
the
start-
group factor, sir?
Group rating.
Group factor.
Group factor कहाँ पर देखा है?
Step 3, step 2.
Derating factor.
Group rating factor, sorry.
Group rating factor is, see, we are
Yes.
not using a single cable in the plant. There are multiple cables are there, right? Because of that, group rating factor will occur. So that depends on the single core and the multi-core. So I am using the condition C because I'm using the multi-core cable. So
Okay.
this condition I'm using, for me, suppose I'm using 3 cable ties and each stage there is 9 cables, so 0.68.
Okay.
I'm using here.
Sir, the starting current we are applying into the voltage drop calculation.
Yes.
Starting current. How could you please explain that one again?
Starting current is basically, as of now, it is given in the vendor data sheet only.
Yeah.
But yes, starting current as of now, you can assume that 8.4 times of the running current for the LV and 6 times for the ST. So this you can do right now.
Yeah. Then how we are considering this into the calculation? This part I want to understand.
This we are using in the starting voltage drop. In the starting voltage drop, I will use the starting current as well as starting power factor. So running current is multiplied by 8.4 here.
Okay.
And this is starting. So this starting voltage drop is coming.
6.01%, allowable one. This is the allowable value, right?
Allowable one is 15%.
Okay.
In case of starting.
Is generally this is standard, sir. 15% for motors, all motors.
Yes.
Okay. Thank you, sir.
Similarly, here I have sized one cable for a transformer to the load. Suppose here the drop margin is 1%. So I will size the cable based on this. For 2.5 MVA is the current. My current requirement is 3477 and it's a derating. Overall is coming 6393, right? But when I will go to the catalog, so I will see that. Okay, let me come to that. So suppose I'm using a copper cable maximum cross section is 630 and it can provide only 660 ampere. But here my requirement is T56393. So what I will do, I will divide this current with the 660, means each phase requires 10 runs. So 10 for R, 10 for Y, 10 for B, and neutral will be half, means that will be 5. So total 35 runs. Okay. Accordingly, this size is done. Clear? Only number of runs will increase here. As a general standard, up to 400 square mm, go for multi-core. And if the cross section is more than 400, go for single core. But it's not a standard, it's a general practice. So that we have easy way in finding out the installation problem is solved. We can easily lay the cable because weight will be lesser, right, in the higher cross section. So we should use like this. Okay. Yeah. Any question on this? Similarly, the voltage drop is a transformer. So no starting voltage drop problem because that is already considered in the transformer sizing. So only that running condition will be verified here. 0.57 and we are getting here limitation of the 1%. So accordingly it is like this. Clear? Hello. I hope you all are listening to me, right?
Yes, yes, yes.
Yeah, yes, please.
Yeah, we are listening.
Okay. Okay, it's 10 for now. I have covered the LV cable sizing part till now. Okay, any question you want to ask? Next will be the ST part, so that I will cover tomorrow. Any question you want to ask in this?
Okay, sir, you
LV
are telling that if the depending as you are telling at last regarding a transformer cable sizing, yeah, we have to do that. If you are going for the number of runs, more number of runs to overcome the situation, okay.
Yes,
So
yes.
at that case, how will be the connections? Will we should discuss with the vendor only?
Yes, no, trip. Why you want to discuss the vendor? I'm telling trip. Go for Trefoil because transformer is an unbalanced load. Trefoil, RYB like this.
Okay.
Let me draw. Don't need to discuss. This is not the first time we are laying this. Everyone know this. Yeah, I will do this. Paint. This is first R. This is first one. Okay. R Y. This is B. Okay. So this is first Trefoil. Second is once again R is Hooper. Here Y B. Then B and Y will be interchange. The cable will be interchange. Here it is B, right? So this will be Y. And this is my first run. This is my second run. This spacing will be 2D. Here 2D spacing will be provided. Accordingly, you will use 13 runs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Yeah.
Like
No,
this.
actually, what my question is that actually we are planning with only single core cable. But at last, by seeing the current rating, we are going with 35 runs. Okay. For the touch current, do we need to discuss with the vendor for the connections purpose? Connections
What type of connection means?
for the
Connection on what?
input and output end of the cable.
Hey, sir, he was asking like for terminal connection, say for the particular any
Okay.
transformer.
Basically, you need to you need to provide this site to the transformer manufacturer. Accordingly, they will make the terminal connection, terminal bushing, so that you can connect these cables. You have to provide this. This is the input requirement for the transformer manufacturer. Okay.
Yeah,
Okay, it's 10:07 now. All the calls are on recording. So you can